My name is Batman Zamani, and in this talk, I'm gonna talk about domain modeling by using this textbook, System Analysis and Design in a Changing World. This is chapter 4 of the book, and the authors are Satzinger, Jackson, and Bird. Okay, so this chapter is about domain modeling. In this chapter, we will learn about these concepts. First, we will see that we want to find the things in the problem domain and show those things and their relationships. For visualizing those things and their relationships, we use two tools. First, entity relationship diagram, or ERD, and second, domain model class diagram, or DMCD, which is one of the UML diagrams. And at the end, to show the behavior of the objects, we will review state machine diagrams, which are UML diagrams for identifying object behavior. So in this chapter, you will learn these topics. You will be able to explain how the concept of things in the problem domain is, and you will see that these things actually they show the requirements, or they deal with the requirements, and you will be able to identify and analyze data entities and domain classes. We will see in this chapter that we use these two terms, entities and classes, interchangeably. You will be able to work with the entity relationship diagrams and domain model class diagrams. And we will work with a case study RMO system for the consolidated sales and marketing subsystem of this case study. And we will see state machine diagrams, as I mentioned, and we will be able to interpret those diagrams. Okay, so one of the main concepts for defining requirements is entities or domain classes. So this chapter focuses on these two items. For example, for RMO trade show system that we reviewed in chapter 1 of the book, we have seen some of the concepts or domain classes like supplier, product, and contact. And for another case study that we have already seen, waiters on call, which was a food delivery system, actually, we saw some of the examples of domain classes like restaurant, menu items, customers, orders, drivers, etc. So what's the topic of domain modeling? The most important task is to identify the things, and I want to emphasize that these things are in the problem domain. So we are not working on the solution yet. We are in the analysis phase, and we deal with the problem domain. So we want to identify those things and their attributes and their relationships. When we talk about problem domain, actually it's a specific area of the user's business that is within the scope of the new system. So just think about the user's business and part of that business which is with the scope of the system that you are building. That's the problem domain. And those things that we want to identify or discover are the items that the user work with. So things are those items that the users work with when they want to accomplish their task. Examples of the things are products, sales, shippers, etc. And you will see later that these are nouns. So when you read the requirements, when you study the requirements, just look for the nouns. Those are the things in the problem domain. And we model these things by diagrams to be able to understand them better and communicate with the team members. For modeling these things, we use domain classes or data entities. For those of you who have already passed database courses, so you are all familiar with data entities. But in this course, we try to use the term class instead of entities. But for the most of the things, they are similar and they are the same. So in this course, we call those things domain classes. But in the database terminology, you call them data entities. Okay, for identifying these things, we have two techniques, brainstorming and noun technique. In the brainstorming technique, you usually talk with the users and try to brainstorm and identify domain classes. So we talk about the usual types of things. Which kind of things do you have in your domain? So we brainstorm and with the team members and with the users and try to identify those things in the domain. In the noun technique, we suppose that we have already documented some of the requirements. So in those requirements, we look for nouns. So when this system is described, we try to identify the nouns in the description of the system and the requirements. And we decide if those nouns are domain classes. And not all the nouns are domain classes. Sometimes some of the nouns are attributes of the classes, or some of the nouns are not important. They are not something we need to remember. So there may be many nouns when you read the requirements, but you must think about it. Do we need them? Do we need to remember them? So this need to remember is actually a criterion that you decide whether or not a thing is actually a domain concept. And do you want to keep it in your system? Do you want to remember it or not? So in the brainstorming technique, you ask these questions. Are there any tangible things? So the things can be different kind of things. As you see in this diagram, you have categories of things. Some things are tangible things. So when you talk to the customer and or when you brainstorm with your team members, you just ask these questions. Are there any tangible things? Tangible things like airplane, book, vehicle, document. Depends on your domain. If you are working in a library system, for sure, book is one of the tangible things. Then you must ask about roles that people can play. So which role can a user have or can an actor have? So employees, customers, doctor, patient, these are things that you can identify. Other things can be organizational units. For example, if you are working in a library, again, maybe you ask the user, which sections do you have? Or if you're working in an educational system, like a college, you may ask, how many departments do you have? So these are all samples of things. Things can be devices, can be sites or locations, can be incidents or events. So in the brainstorming, try to identify as much as you can things from different categories. Here are some steps or guidelines on how you can do brainstorming. So you first, we suppose that you have already have a set of use cases and you know the user. So you brainstorm with the user and try to identify things. And the things that the user is using or working with those things when he or she is carrying out the use case. So things about which information should be captured by the system. So this is important criterion, as we mentioned before. And then you brainstorm about type of the things. And then when you have a list of things, you try to not to miss any type of users and stakeholders. So you brainstorm with different users and stakeholders to expand the list of things that you have identified. And finally, you merge the results, the list of things, and try to eliminate duplicates. For example, in one domain, maybe in a college system, a user talks about teachers, another user talks about professors, and you may say that these teachers and professors are the same thing, so you don't need to keep both of them, and you just remove the redundancies and duplicates. So you will reach to a list of things that you have identified in that domain. You may apply brainstorming and then noun technique, or vice versa. You may apply both of them, or you may apply just one of them. So why there are two techniques? Because we want to identify as much as we can. We want to identify as many things that we can. So in noun technique, you try to identify the problem domain classes or things or entities by finding, classifying, and refining list of nouns. So you try to focus on the nouns. So when you read a sentence, which is a requirement, you just underline the nouns. Those nouns are potential things. Why I say potential? Because not all the nouns are important, and maybe we don't need to remember all of them. So it's important to actually exclude those nouns that you don't want to remember. So it's a popular technique and it's systematic, this noun technique. But as I said, you need to have a list of requirements and just you underline the nouns. So you will have a long list of items. And as I said, not all the nouns are things. So you must think about this criterion. Do we need to remember them? Do we need to store them in the system? Then if the answer is yes, those are the things. If there are synonyms, and if you want to decide whether or not a thing is really a class or is an attribute. This is the difficulty of this noun technique. For example, when you have a chair, yes, chair is a thing, or the one of the furnitures that you will sit on is a chair, but you have also color as the noun. So color is not an entity. Color is actually an attribute of the chair entity. So not all the nouns are entities. When this noun technique is good technique when you don't have access to the users to do brainstorming with them. So you have a list of requirements and you just use this noun technique. Okay, there are some steps for this noun technique. So you have use cases, you have actors, and you have some other information about the system. So we try to focus on the inputs, outputs, and requirements, and you try to identify all the nouns. For example, for the RMO CSMS, some of the nouns could be customer, product item, sale, and these are all potential things that you can discover in this system. So you use other sources of information to identify more nouns, more things. So you use the procedures, the reports, the forms, and then you try to come up with more things. So, for example, you have price, you have size, you have color, and as you see, some of these are things, some of these are attributes of things. So you must come up with this information as well. And then you have a list of nouns, you try to refine them, and then you want to identify which of them are things actually, and you want to include them. And also you must decide which entities you want to exclude. So if you answer these questions, maybe you can decide to include those nouns in the list of things in your system. Is it a unique thing that the system needs to know about? Is it inside the scope of the system? Some of the nouns are out of the scope. For example, if you're talking about a classroom in a college, so maybe there are lights in the classroom, but turning on the light is not in the domain. So the light in the classroom or number of lights in the classroom, they are not in your domain. So if you see some of those entities, they are out of scope and you don't need to include them. Also, you ask some questions to exclude the entities that are out of the domain or are redundant. For example, if there are synonyms for some things, as I mentioned, teacher, professor, maybe in a college system, they are the same. So we don't include both of them and we exclude one of them. So some of the things you are not sure about it, so you must research about it. So for example, if one of the nouns that you find is some piece of information that's an attribute of some other thing, that's not an individual thing. As I said, color of a car, for example. So you in one system you have car, that's a noun, so that should be an entity, but the color of car is just, it's a noun, but it's not a thing, it's an attribute. And you must ask if some assumptions is changed, do I need to do something? So this is about researching about the things to make sure that you have identified the correct thing and you understand what does it mean. So you have a list of nouns identified, and then you include, exclude, or research some of the nouns, and finally you review the list with the user and with the stakeholders and team members to have a finalized list of things in the problem domain. So that's the result of the noun technique. And as I said, you apply the brainstorming and the noun technique, and now you have a list of concepts in the problem domain. Here are examples for the RMO system. Here are list of nouns, and then you think about these nouns. Do you want to keep them? Are they things in the system? Are there things important to store? For example, you have a bank concept in your system, but when you see there's only one bank and your system doesn't care about the bank, so you decide not to include this entity in your system. So you decide about these nouns that you have identified and whether or not you want to keep them. And the list goes on and on until you actually polish the list and reach to a finalized list. For example, color here is not an entity, and it's just piece of information about a product item. So it's an information about a thing, about another thing, or it's an attribute. Okay, so far, the things that you have identified, or we call them domain classes, they have details. And as I mentioned, some of the nouns that you have found are attributes of those domain classes. So for the domain classes that you have identified, you want to extract more details like attributes of the domain classes. As you all know from object-oriented concepts, so each class can have some attributes, and attributes are a piece of information about instances of that class. For example, a customer can have first name, last name, phone number. So name is a noun, phone number is a noun, but those are not classes. Those are attributes of a class called customer. Another point that you must pay attention is to identify the identifiers or keys for those classes or for entities. So as you know, key is an attribute that uniquely identifies an instance of the class. So when you discover some of the classes or entities in your system, you must think about their key. For example, for a customer ID is a good candidate for being a key, and you decide about this attribute as the key. Sometimes the attributes are compound attributes. For example, maybe you want to have first name and last name, and you combine them as name attribute. Or sometimes you have address, which includes several other attributes. So you must decide whether or not you want to keep separated attributes or you want to combine them as a compound attribute. Here are examples for customer. A customer is a class that we have identified. So the customer can have these attributes. And here, to make sure that you have identified appropriate attributes for the classes, you may want to look at some real-world objects. For example, here about the customer, you have ID, you have first name, last name, home phone, and work phone. And here are 3 different objects that shows the values for these attributes. Okay, after identifying the classes and their attributes, you must think about the associations. So associations among things means the relationships between the classes. So in UML, association is a general relationship between the classes. Here is an example of some of the relationships in real world. As you see, we have some objects here, Mr. Smith, which works in accounting department. And Mr. Smith has placed an order number 1043. So these are in instances of some classes. How many classes can we see here? We see class order, and now we see an instance of class order. We see Mr. Smith, which is an instance of class customer, for example. We see accounting department, which is an instance of class department. And as you may guess, now we have the relationship between the order and the customer, and the relationship is called places or is placed by. You can read it from left to right or right to left. And this diagram is showing the objects. Please pay attention that this is not a UML diagram. This is a kind of object diagram, and that shows some of the real-world objects. And here you will see another relationship or association between order and order item. So this is an item, and each order includes or contains several items, in this case, 2 items. So these are relationships between the things that in UML term we call them association. Maybe in database world, in entity relationship diagram, we call them relationship. So to clarify, the relationship between the classes in UML is called association, and the relationship between the entities in entity relationship diagram in the database world is called relationship, but they are the same thing and they have the same meaning. And each association can have multiplicity, which is the number of elements which are playing in the relationship. And for the relationship, you call them cardinality, which is the same number of entities that are playing role in a relationship. And as you all know, the relationships and the cardinality for the relationships could be one-to-one, one-to-many, or many-to-many. And the same for multiplicity of associations could be one-to-one, one-to-many, many-to-many. So in this book, we focus more on the UML concept. So we use the words class and association instead of entities and relationships. Again, remember that associations and relationships, they have two directions, and when you read them, you must think about both directions. So you must read them separately each way. For example, you can say a customer places an order, and the other way you can read it as an order is placed by a customer. So as you see here, the customer and the order, there is a relationship. So an order is placed by a customer, or a customer can play an order. So an order or many orders, this is based on the cardinality. So each association can have minimum and maximum cardinality. So these are called minimum and maximum constraints. When the minimum number of, for the cardinality, the minimum number is 0, we call that association optional. When the minimum is at least 1, we call that association mandatory. So here are some examples that we reach to a conclusion that what is the cardinality. When you have in your reports in the documents that you have studied about the system, you will read this sentence that says, Mr. Jones has placed no order yet, but there might be many placed over time. So here you are talking about an association from Mr. Jones to the order, and here is the multiplicity that you will conclude to have. So it's 0 or more, the relationship between the customer and the order. And another example says a particular order is placed by Mr. Smith. There can't be an order without stating who the customer is. So this is a mandatory relationship, and that means the order, the relationship between the order and Mr. Smith is many to 1. So the multiplicity is 1 and only 1 on the side of the customer. So in the associations that we talked about, and it was relationship between the classes, there are different types of associations. When there are two classes that are playing a role in an association, there are two different classes. We call that association binary association. So association between exactly two different classes. For example, we say course includes students, or course section includes students, or members join club. So here we have two different classes, and the join is the association. This association is binary association. But sometimes there is only one class which two instances of the same class play a role in a relationship. So associations between two instances of the same class, this is called unary association. And also we call it recursive association. For example, if you have a person class and there is a relationship between a person with another person, so in UML, you have a box for person, and there is a line from person to person. That line is association, and you call it married to. This is the name of the association, and this association is unary because it's between two objects of person class. Sometimes there are ternary associations when there is three things from the three different classes. For example, a movie actor can play in a movie which is recorded in a studio. So the relationship between the movie actor and studio is a ternary association. Sometimes the association is n-ary association when there are n different objects. Okay, now we talk about entity relationship diagrams in this chapter. Although our focus is on class diagram, but let's review entity relationship diagrams that shows both the entities and their relationships. So in entity relationship diagram, which actually is for designing databases, we identify the entities in the problem domain and their relationships. So you all are familiar with entity relationship diagrams. Is a diagram consisting of data entities, which we show them by rectangles. Their attributes, which we write under the name of the entity in the rectangle, and the relationships, which are lines or diamonds that connect two entities together. So in the ERD, the things that are discovered, they are called data entities. But in UML models, we call those things that are identified as classes. Remember that ERD is not a UML model, and UML is a more powerful language for visualizing and documenting systems, because in UMLs you have generalization, specialization relationship, you have whole part relationship, which in ERD you don't have. So here is a notation for ERD. Boxes are used for the entities and lines are used for the relationships. And this is Crow's-Foot notation. In Crow's-Foot notation, actually, you have this notation for showing the cardinality of the relationships. For example, here is 0 or many, here is 1. So what does this diagram say? It says a customer can place 0 or more orders, and any one order is placed by only one customer. So it's from the customer to the order, it's a one-to-many relationship. From the order to the customer is many-to-one relationship. And this is an optional relationship because the cardinality is 0 here. So these are different notations that you have in ERD for 1, 0 or more, 1 or 0, and 1 or more. And in this diagram, you will see 3 different entities with relationship between them and with different cardinalities. And also, so here is the entity called customer. Here are the attributes of the entity, and you will see the primary key. So in database, it's important that each entity has a unique key, and you decide which of these is called key or is considered key. So this diagram, for example, shows a customer can place many orders. Each order contains many one or more items, but each order item belongs to exactly one order. So it's one to many from order to order item, many to one from order item to order. Okay, there's another concept called semantic net. If you want to see actual data and have better sense of what are the entities, what are the relationships, you use this semantic net. Semantic net is a graphical representation of an individual data entity and its relationship. So you will show the entities and their relationships, but for individual data, for real world data, for actual data. So it helps you understand and develop ERD model. Here, for example, is a semantic net that shows some of the customers and some orders they have and the order items that are included in their orders. For example, here you will see that customer Mary has no order yet. So this means that the relationship between the customer and the order could be 0 or more. So a customer can have no order yet. So here you must be able to identify the classes. Remember that these are real world entities. So John is an instance of class. So what is the class here? The class actually could be a customer. So John is a customer. Mary is another customer. So we see class John, class Mary, and we see class customer and 3 instances, John, Mary, and Sarah. So one class is customer. The other class is order, and you will see different orders here. They are different objects. And then you will see order item. So what are the classes here? Customer, order, and order item. How many relationships do you see? Actually, there is a relationship between a customer and order, but because the relationship is one-to-many, you will see one relationship between object John with object order 1 and relationship between object John and object order 2. So these are instances of the relationships. So if you want to count these relationships, these are instances, you count them. But in terms of classes, you have class customer and class order, and there is one relationship between customer and order. And then you will talk about the cardinality of both sides of the relationships, and if the relationships are one-to-many, many-to-one, or one-to-one. So here is another example for an ERD about a banking system. And as you see, a customer can have one or more accounts, but each account belongs to only one customer. So here is a relationship. If you want to name this relationship, what do you call this relationship? This can be a has or own relationship. Customer owns an account. An account is owned by a customer. And here are attributes, and one of the attributes is called primary key. And you see different relationships, and you can think about these questions. What are the keys? So keys are clearly identified here by PK. And how many accounts can a customer have? So a customer can have one or more accounts. So this cross-foot notation shows you the multiplicity and the minimum or maximum of multiplicity of the relationships. Okay, as I mentioned, instead of entity relationship diagram, there is another tool which we call it domain model class diagram. But remember that class diagram is a UML diagram which has 2 applications. One is in the analysis phase, which we call it domain model class diagram. There is another application for class diagram, which is design class diagram or DCD. So we use class diagram for 2 purposes. One is for analysis, which shows the domain model. And what is domain model? This is the topic of this chapter. The entities or concepts in our model, in our domain, and their relationships, and for sure their attributes. So we use a UML diagram called class diagram to show domain model. Okay. So there are different approaches for system development, but in object-oriented approaches, we use domain class rather than entity. Okay, so in object-oriented, we use domain, the concept class. And you all know that a class is a set of actually real-world entities, and we make actually common concepts for these objects in a class. So it's a category or classification to describe a collection of objects. Domain class is classes that are in the problem domain. So if you include some of the classes and you consider them from the business domain, so they are called problem domain classes. And class diagram is a UML diagram, as I mentioned, that shows the classes, their attributes, and their associations, similar to entities, attributes, and relationships, remember? So in class diagram, you can have methods for the classes, but for software classes. But here, because we are focusing on domain class diagram, in domain class diagram, we don't have methods. So this is an important point, guys, that for class diagram that we draw for as a domain model, we don't show methods for the classes because those classes are domain classes, not software classes. Maybe later in the design phase, we will decide to write a class for this or design a class for these concepts. Those are software classes, and for sure we should indicate methods. But maybe some of these domain classes, they will be merged into one design class. Some of them, they will disappear. So in this phase, which is analysis, we don't have methods for the classes in our class diagram, which is called domain model class diagram or DMCD. So we use UML because it's a UML class diagram. It's a UML diagram. We use UML notation. So again, domain classes, they have names and attributes. And each class is shown by a rectangle. And the rectangle has two parts. On top, we write the name of the class, capitalized, the same as Java. So in UML, we capitalize the class name. And in the second compartment of the class, we write the names of the attributes, and attributes are written as camel case. So this is the notation that we must use. And for the relationships, now we call them associations. One of the general and typical associations is called association itself, and it's shown by a line. You can have arrows for the directions, but for now we don't put arrows. And when we don't have arrows, that means these two domain classes, they have visibility to each other. And for the associations, we have names and we have cardinalities. Cardinalities is similar to entity relationship diagram, can be one or more, zero or more. So here we have three classes: customer, order, and order item. And one customer can place zero or more orders, and one order can contain one or more order item. And if you rate it from right to left, each order item is consisted in only one order, and each order is placed by only one customer. So one order cannot be placed by two customers, but one customer can place no order or one order or many orders. So this diagram actually matches the semantic net that we have shown before here. This semantic net helps us to realize this ERD or this class diagram. So these are the interpretations of this diagram. A customer can places zero or more orders, etc. You can interpret this. As I mentioned, for the associations, you have multiplicity in UML. So you have zero or one, exactly one or more. When you have star, this means 0 or more. So these two are the same, 0 or more, 0 or more. You have two options for the associations, for the cardinality of the associations. So here is an example in a bank domain, the domain model class diagram for a bank domain. So a bank with many branches that we have seen in the ERD now is drawn in class diagram. You see we have classes customer, account, branch, and transaction. As you see here is a tangible thing, customer. Account is not a tangible thing. I think, yes, but it's something that you want to remember and you want to keep record of. Branch is a tangible thing, and transition is not a tangible thing. It's actually an action that happens and you want to keep record of them. So think about the different categories of things, and you will see that these two are tangible, but these two are not tangible things. And each customer can have some attributes. Account can have some attributes, branch the same, and there is association between customer and account, and there are multiplicities. And there is no name for this association, so it's good to think about these names. What is the good name for this association? A customer has or creates or owns an account, or an account is owned by a customer. An account belongs to a branch. An account has many transactions or includes many transactions. So as you see, one account can have one or more transactions. That means we don't have any account without any transaction. So this is why here it's not 0 or more. That means this is why when you go to a bank and you create an account, they ask you to do a transaction, even if it is $1. Okay, so this is why when you create an account, immediately you have a transaction to actually realize that account. And each transaction belongs only to one account. But in a branch, you can have 0 or more account. That means maybe there is a branch of a bank, but there is not any account yet. But a branch can have many accounts. The same way, if you read it from left to right, an account belongs only to one branch. An account belongs only to one customer. So this is not a real case. Yes, some banks allow co-owner of the account. So an account can have one or more customers. But in our, these are based on the policies of the domain. So when you talk to the user says, in our system, we don't allow customers to have joint account. So an account can have only one customer. And another difference between entity relationship diagram and class diagram is the notation for key. As you see, you use the term key inside braces to identify that this is the key. But remember, this is not entity relationship diagram. This is a domain model class diagram. And if the name of the class is written as italic one, that domain name is, that class is abstract. So because these are domain classes, maybe you don't want to say abstract classes yet. Okay, so here another example for domain model class diagram. This is about course enrollment at a university. So if I give you this diagram, you must be able to interpret this diagram. I think you can write at least 10 lines of text about this. So in this system, we have courses, we have course sections, we have students. Each course can have 0 or more sections. In each section, we can have many students registered, 0 or more students. So here, as you see, there are associations, but there is no association name. What's a good candidate name for this association, course and course section. Has maybe. So a course has many course sections. What's the good name for this association between the course section and student? Maybe register. So student registers in a course section. And a course section is registered by many students. And as you see, the relationship between the student and course section is many to many. So if you look at this diagram, maybe you think about a problem here, not a problem, a difficulty. Most of the time when you have many to many relationships in ERD, if you remember, you have defined entity sets here and you have defined relationships here. Here, if you see a student registers in a course section, and then for each course and each section of a course, a student may take a grade, may have a grade. So where do you save the grade? If you save the grade in the student, it doesn't show for which course. If you save the grade in the course section, it doesn't show for which student. So here we need to actually save the information about the registration of one student for each course section and save the grade in that information, part of that information. So here we need to keep information about the association itself. This is called association class. So we add a class here, we connect the class by dotted line to this association, and we put this grade as the attribute of that class. This is called association class. So we have to refine our model domain class diagram with adding association class for course enrollments. So this class, which is connected to an association by a dotted line, it's called association class. So don't forget this term, this concept, association class. And the grade is an attribute of this. So this class actually is a placeholder for keeping the information about this association. And this association was called enrolls, yes? Student enrolls in a course section. So association class is treated as a class in a many-to-many association because it has attributes that needs to be remembered. So this association class is used in this many-to-many relationship to keep the information about this association. Okay, the property of the association. So the association class is the same thing as the association itself. So here is this class student is the class thing. Yes, so it is, sorry, is a student thing, is a tangible thing. But here, this association class is a thing that shows this association. So this is what we are talking about in this slide. And you remember for the keys, if you want to define the key for the association class is a concatenation of the keys of the attached classes. So in the many-to-many relationship, when you have a association class, so the key for this comes from the key from the both sides. So you, for this grade, you must know for which section and for which student. So it will actually inherit the keys from both sides. So the key for the course enrollment is the course number, section number, and it's so section number and student ID. And actually you need the course number because this section belongs to a course and you have the course number also here. So course number, section number, and a student ID. Okay, so here is an example that shows the relationship between the members of a band and a concert that they are playing in. So each member belongs to exactly one band but each band can have one or more members, and each band can play in 0 or more concerts, and in each concert you can have one or more bands. So there are relationships here, and you can think about these questions and answer those questions. Again, if you want to have information about this relationship, that where is this concert and in which date it is, so you have, or about the booking of this concert, so you may have association class called booking, that if you have several bands playing in a concert, you want to know in which order they play. So here is an association class that gives you information about this association. Okay, there are different relationships between the classes. These associations is the basic relationship between the classes, but there are different kinds of relationships. And here is the point that we prefer to use domain model class diagram comparing to entity relationship diagram. So more complex associations okay, so with the class diagrams, we have different relationships, as I mentioned. Association is the basic one that we discussed, but there are other relationships between the classes. For example, generalization, specialization is another relationship, which you may remember it as superclass, subclass, and the whole part relationship. So these are three different associations between the classes, or different relationships between classes. So association was the basic one, which we show it by a simple solid line. Now let's talk about generalization and specialization. If you have past object-oriented courses and you have written object-oriented programs, you all are familiar with this concept of inheritance in Java, C++, any object-oriented language. So generalization, specialization, or inheritance is a hierarchical relationship when subordinate classes are special types of superior classes. So subclasses and superclasses, we call it inheritance as well. So we have superclass and we have subclass, and the relationship is inheritance. So subclasses inherit characteristics of the superclasses. You all know this concept. Here is an example. So in UML, remember that inheritance or generalizations, specialization is shown by this blank triangle. So from the subclass to the superclass, you have this arrow, and don't forget that this is not a solid triangle, this is a blank triangle. So here we have a general concept or superclass motor vehicle, and we have three subclasses: truck, car, and tractor. And we have three different types of cars: sports cars, sedan, and sports utility. And you may remember that this relationship sometimes is called is A, and you can read it: a car is a motor vehicle, a truck is a motor vehicle, or a sedan is a car, a sports utility is a car. Okay, here is an example. We have three different kinds of sales. So in-store sale, online sale, telephone sale. They are all different kinds of sale. Here, as you see, the sale class is written as in italic. So when the class is italic, that means the class is abstract. So abstract class is a class that allows subclasses to inherit characteristics, but they cannot be instantiated. So we cannot have objects of class sale. Actually, there is no sale unless we have in-store or online or telephone sale. If we have one of these sales, we have a sale. But if you don't have any of these, We cannot have a sale. So actually you can instantiate in a store, online, or telephone sale. And as you know, all these three subclasses or children classes, they inherit all the information from the parent class or superclass. So 1, 2, 3, 4, 5, 6 attributes are inherited here. In addition to these 2 attributes, we have 8 attributes for the online sale. Okay. So here's an example for a bank system. So you have accounts, but you have 2 different accounts, saving account and checking account. And as you see, the account is abstract. So each saving account inherits 3 attributes from the account, and it has one attribute for itself. So saving account will have 4 attributes: account ID, date opened, balance, and interest rate. And remember, the saving account inherits the relationships as well. So a saving account is created by a customer, and each customer can create a saving account. So the relationship is also inherited. Okay, so the subclasses inherit the associations too. Okay, another important relationship between the classes in UML is called whole-part relationship. So a relationship between the classes where one class is part of or is a component of another class. For example, a computer is actually a collection of parts. A computer can have processor, main memory, keyboard, etc. There are 2 different types of whole-part relationships. So these whole-part relationships can have 2 different types: aggregation and composition. What are these 2, and how do we show them in UML class diagrams? So aggregation is a whole-part relationship where the component parts can exist separately. Aggregation is shown by this. So from the whole to the part, but you put a empty diamond for the whole side. Composition is a whole-part relationship where the parts cannot exist individually. So here is the whole, here is the part, but the parts are dependent on the whole. They cannot exist individually and independently. So let's see some examples. Here you have a computer, and here you have a hard disk. Yes. So a computer contains a hard disk, but we can have a hard disk without having a computer. And many of the computer stores, they sell storage devices like hard disk, and also they sell computers which include hard disk. So this is the whole part relationship that the part can exist separately. Or a car can have wheels. So you can have wheels and you can buy wheels independently. But for the whole part relationship, when the part cannot exist independently, we call it composition. And you write the whole item here and the part item here, and the part item cannot exist independently. For example, order item and order. So here is order, here is order item. We cannot have order item without having an order. Or chips and circuit. So a circuit contains some chips. You cannot have chips, chips and circuits. So each chip is a whole, it can have circuit. So without a chip, you cannot have a circuit. These are compositions. So here, let's see an example of whole part relationship, which is aggregation. So it's between a computer and its parts. And as you see, it's a weak whole part, which we call it aggregation, and the parts can exist independently. For the composition example, suppose that we have a house which consists of bedrooms and bathrooms. You cannot have bedroom without having a house, yes? So if you want to draw a UML diagram, you can have a box or a rectangle for house, and then you must have a solid diamond, and then you can have a another concept for bedroom. So here is house, here is bedroom, and remember here it's a solid diamond. This is the UML diagram for the house and the bedroom. Okay, so remember there are three types of relationships in class diagrams, hence in the domain model class diagram. Association is a general relationship. You show it by a solid line. Whole part relationships and generalization, specialization relationship. You shouldn't confuse the relationships with the associations, okay? So association is a general kind of relationship, but you have whole part, you have generalization, specialization, or inheritance. Another point to remember, we use UML class diagram both in the analysis and in the design. So in the analysis, it's called domain model class diagram, and we use it to identify and visualize the domain concepts and their relationships. Also, we can use this UML class diagram in the design phase, which is called design class diagram. Again, in this diagram, we show the classes and their relationships, but they are solution classes, not domain classes. And remember, in the domain model class diagram, they don't have attributes, the classes, they don't have methods, the domain classes, but in the design class diagram, they can have methods as well. Okay, here are some examples for the consolidated sales and marketing system for RMO project, the domain model class diagram. So there are 27 domain classes that are identified, but you can show the domain model class diagram per subsystem if you want to have not have a busy and large domain model. You can partition it into different domain models for different subsystems. So here are different subsystems. For example, a sales subsystem. This is the domain model class diagram for the sales subsystem. It's important if you review this diagram and try to interpret it. It's very important if you are able to read this diagram and write all the information that you can catch. This is the whole point of the diagram, that team members can have the same understanding from the system. For example, here you will see that we have 3 different sales, and the sale is abstract. That means we don't have sale if we don't have any updates. And here we have 2 different online cards. So these are generalization, specialization. Here we have association class. That means this information are just storing information about this association. What is this association? What are the promotions for each product item? So for each promotion, we want to see the regular price as well as the promotion price. And relationships between all different classes are shown here, and you must be able to interpret. So this is for the sales subdomain. Here is another domain model class diagram for the customer account subdomain. Okay. Note that some of the classes are repeated here. For example, here we have customer, and in the sales domain, also we have customer in the account domain, and those are the same classes. Okay, so this is not redundancy. We draw this class again here because in this domain, customer plays a role, but finally you merge this into one big merged class diagram, which is this one, and then you have only one customer. Okay. Try to review and understand this diagram and be able to write some descriptions based on this diagram. Okay, so there are other subsystems that are not shown in these slides: order fulfillment, marketing, reporting, and you can read chapter 3 of the book about these subsystems and try to design your class diagram for these subsystems. And remember that you can have duplicates in the subsystems. Okay, the last topic for this chapter is showing the behavior of the objects. I try to make it short. The slides are more. So far, we talked about the static aspect of the system, but sometimes the objects have behavior. So when you want to show the behavior of the object, you must talk about the state and the transition. So why do we care about the object's states? Because you must understand the system very well, and some of the objects, they have behavior. So suppose that there is a business rule in the RMO system that says customer sale shouldn't be shipped until it has been paid. So as you see, these are states of a sale, okay? So a sale can be shipped, can be paid. So we need to know the status of a sale. Is it shipped? Is it paid? So each class has objects, and those objects may have states. So object behavior shows the various states and the movement between these states, which is called transition between the states. So by a UML state transition diagram, we want to show the behavior between the objects. So you must understand the meaning of state. State is a condition during an object's life which satisfies some criterion and performs an action or waits for an event. And transition is the movement of an object from one state to another. So if you show the states and their transitions, then it helps you to analyze the business rules and understand the business rules. So we use UML state machine diagram. Also is called state transition diagram. So it's one of the behavioral models of UML. It's dynamic model and shows the life of an object. Remember, we show the behavior of an object, just one object. So focus on one object if it has states, and then see how many states does it have and how it moves from one state to another, okay? Not all the classes require a state machine diagram. You just focus on those that you need to remember their behavior. The notation for the state machine diagram is simple. So we have these rounded rectangles for showing the states, and we have these arrows for showing the transitions. So state and transition, but we have some states called pseudo state, like start state and stop state, the same as flow charts that you have start and stop. So here you have start and stop as pseudo states. For each transition, you have origin state and destination state. And for each transition, you have action and guard. So let's have a look at the syntax. here, for example, you are seeing a state machine for a printer. Okay, so what are the states of a printer? Very easy. A printer can be in off mode or on mode. So there are two states for a printer, off or on. When it is off and you press the on button, it goes from off to on. So forget about this condition and action. So each transition, this is a transition, this arrow, and for each transition, you have transition name, you have condition or guard, and then you have action. So if the button on is pressed and safety cover is closed, then you run the startup and you go to the on condition, on state. So for now, you just write the name of the transition on the transition line, and we forget about the condition and the action. So what happens when you press the off button in the printer? It goes from the on state to the off state. And you have a pseudo state here, which we show it with a solid circle. That's kind of start state, and means that when you want to work with the printer, you think that at first it is in the off state. Then you press the on button, it goes to the on state. Then you press the off button, it goes to the off state. Sometimes these two buttons is one button. Yes, you press it, it goes to the on, you press it again, it goes to the off. So this is the state machine diagram or state transition diagram. So sometimes there are concurrent states to show the concurrency, and you use this fork and join notations to show different states. And actually, as you see, these states and these transitions must happen to be able to move to this state. So I've ignored these complicated transition diagrams. We just state transition diagram. We just use simple notation of states and transitions. But remember, state transition diagram doesn't show sequence of actions. It shows the states. So here is an example for a printer which has two states. If you look at a microwave, it can have several states. Yes, off, on, door open, door closed, timer on. So you just show different states of a microwave and what happens or what causes the microwave to move from one state to another state. So I wrap up my discussion here. I just ignore the other slides. Yeah, just to show an example, here is state machine diagram for a sales item. So a sales item can be ready to ship, can be shipped, can be on back order, and these are the transitions between different states of a sales item. So if you have these items, these states, then you can have pseudo states start and end. This is a state machine diagram for a sales item that shows different states and the transition between the states. Here are the steps for creating state machine diagram that I will just bypass them to reach to the end. And here is the summary. So I don't repeat the points because it has been a long lecture, and I want to thank you all for following the slides and listening to this lecture. Have a good day and bye.